Hey everybody, Richard here with WingSmith drones. Carmen's just in the other room. She'll be joining us in just a second, and today we're going to be doing a live stream on Saturday. So, as is tradition, cheers everybody. I got my dog mug out today. Carmen's got her cat mug. We got a couple of dogs on here that, like that little guy right there. We got a dog called Charlie, and if I show you him, you'll think he's right off this mug. We like to describe him as desperately enthusiastic. No luck?
No luck.
Okay. Hey everybody. Here's Carmen.
Hello. Good morning.
Morning. I was just describing Charlie on the dog mug.
Oh yeah.
Here we go. Tink?
Mm-hmm.
Okay. Hey everybody. Tink.
Take.
You're part of the team now. All right, let's get started. We got an hour to roll through as much as we can today. So I'm gonna flip you around, and I think we'll kind of do a smorgasbord of stuff. We got our SyncMode V2. I'm gonna show you guys a little bit of what's going on here. Talk about some options that we can do for a camera mount on the front, and what we're looking at the back for a GPS holder, because GPS has been super mega popular in what people are asking for. And so we'll talk about it and what it can do, what it can't do, and why we didn't put it at the front. I've also got a SyncMode all bagged out here. This is like what Steve with BetaFlight is going to send you if you order it. And this is consistently one of the highest rated freestyle frames. Like, this thing has been really just optimized for a kind of bando freestyle style of flying. And so we'll walk through just what the pieces look like, and then what the assembled Lego set looks like. And we've got our battery charger if we want to talk about some battery safety, and maybe we'll do a little bit of soldering, and if time permits, we will get into some BetaFlight. So it's warm here in Saskatoon. Hopefully everybody's staying nice and cool, and we're gonna jump in. So let's talk SyncMode. And you guys can just let me know if I'm talking too much. Hopefully, Carmen. Okay, sorry, we might have lost you guys there as we did a transition from talking above the desk to talking at the desk. All right, so what's a SyncMode? This is a SyncMode. SyncMode is a frame designed by Steve out in the UK. He has a company called BetaFlight, and normally you'll find him really responsive on his Discord, and he makes some absolute banger frames. So the idea is basically that what makes this frame unique is that it's got a true X design. What that means is that you get a real X rather than something, say, like this half-built quad mula. This guy has basically what's like almost like an H design, but it's a squashed X. So you'll have these two arms, and they're linked on kind of this angle, but they're not meeting right in the middle. And so the difference basically comes down to your ability to flip like a gymnast, and things like your prop wash and your top speeds. So I'm not going to talk about the quad mula too much today. This guy's just a kind of like shown for an alternative, so you can see the arms.
And then also props on the camera.
Yeah, and the props are a bit much, but this SyncMode has a couple of unique features. Probably the most obvious is that it's got a carbon, basically cage around the camera. Most of the other drones are going to have something smaller, so this is like the Hummingbird, and you can see it's got this 3D print, and there's advantages and disadvantages to both. This guy is a much bigger, much heavier, much faster, much more flippinest bando frame. So the idea is this thing needs to be able to take a hit and bounce right back. So you can see that even on the cage, it's got pretty thick carbon. I think that's 5mm, but let's just check. Get our calipers out. Oh, excuse me. It's only 3.5mm carbon. And then the arms are your classic 5mm. I'm not sure if you can see that, but these arms are super mega thick. They are intended to be able to take a hit and bounce back. The cage is 3.5 millimeter thick pieces of carbon, so one on each side, and then with some aluminum standoffs in between. And you can see that the 04 Pro unit is sandwiched right in between there with a TPU mount. So you screw this guy into that TPU mount, and then it fits in using the SyncMode logo there on the side, fun fact. And then it screws in on each of these standoffs. There's 4 in total, so you get like a super solid frame, basically. Like, this cage is not going anywhere, and vibration is somewhat limited because you've got that TPU mount. If you're really trying to eliminate vibration, something like these Quadmula cages excuse me, are a little bit, I would say a little bit better, because they're just a lot softer. The carbon on here is going to have basically no flex at all, whereas the TPU, just because of the volume of TPU, it's such a soft material that you're going to reduce quite a bit more vibration. And then this camera is actually kind of just sitting in there. There's these grommets that are, I'll have to show you on the side. There's these grommets that are at the top, and you feed the screw through into the camera. So that would be considered like hard mounting. But then at the bottom, it's just sitting kind of inside there's the grommet mounted to the camera, but then it's just like placed inside this cage. So you get a little bit of hard mounting, a little bit of soft mounting. So if you're worried about vibration, the Quadmulas tend to be just like a little bit softer and a little bit more, let's just say like a little bit less susceptible to the DJI 04 Pro vibration issues. But if you're looking for absolute ruggedness and like a real basher, then Superfly makes the best. They make the best ones. So you can get this in 2 different styles, with this blue carbon and with the black carbon. And basically that's kind of the special bits, other than things like how the arms are mounted at the bottom. You've got many screws in a frame like this, and right now we don't have the footies on here, but that's part of what we're going to do today. Let's just try to install the footies with some 10 millimeter screws. And then we've got our ELRS at the back here, we've got our ELRS on the side, and both of these are part of our HD0 stack that's in the middle. And so it's a pretty squashed design. You don't have a ton of room to work with, and so the actual like racing stack works really well in this frame because it's so low profile. We do also do the Flywoo H743, which is quite a bit like taller, and that's the limit. Like, I wouldn't really put anything bigger than that in here. I know you can do your Squire, you can probably get away with that in here, but for a 5-inch frame, it actually ends up being relatively tight in terms of your vertical distance. You've got lots of like XY play, but not a ton in your like Z axis. Then we've got our capacitor and our beeper mounted in here. This is just the ViFly Finder V2, and all of the drones come with a beeper, because the easiest way to lose your drone is to fly into some grass and basically not be able to see it. So we have brought in GPS. GPS is a thing that we support, and I am a fan of it in certain circumstances, but honestly, a beeper is hard to go wrong with. Like, you'll always be able to track down a beeper as long as it's powered. And on the 5-inch models, it's got its own battery, so even if your battery ejects, total catastrophic crash, your beeper is going to be putting out like 105 decibels in addition to the D-Shot that's set up with your motors. So your motors, even if they're stuck and you can't run them, at least your beeper is going to be something that you can track down, and it's super loud. Your GPS is good for things that are like long range, but to be honest, the GPS is quite a bit more complex. You can do things like return to home with a trigger and as a failsafe. But if you launch without your GPS having enough satellites, then it is not going to have those features. Like, the drone will totally let you launch without getting a satellite lock, but if you don't get it, it won't know where home is. And so it won't set home halfway through the flight. You'll just basically be armed and flying without GPS. So you gotta be on top of how to use this as a tool. It's really great when you're doing something at distance, or you're going to be, a little bit longer out and you need to actually get close enough to hear your beeper. But it is not a get out of jail free card. It is something that you plan around and that you set up properly, and we'll do that, but we don't do things like a magnetometer. They're basically just, you need to calibrate those kind of regularly and as you change things on the drone. And so we have brought in, and also BetaFlight just doesn't support a magnetometer. Like, there's nothing in BetaFlight that directly supports specifically the compass. The compass just adds some features, especially if you're doing things like automated flight and things like iNav or ArduPilot. But in BetaFlight, the kind of advantages of a compass are limited and the added complexity is high. And so we've basically gone with just a regular M10 compass. It works great. You just literally set it as a home position with 8 satellites. You just wait. It's super simple. You plug your battery in. You just wait for the satellites to connect, which will be displayed in your OSD or your on-screen display. And as soon as you've got it, you can arm and fly away. It'll be great. So this is an option. The GPS would mount just behind here, and it's got a 55-degree angle to see the sky. So you're doing great. And then these guys are coming out at a 55-degree angle as well, so that there's the least possible amount of interference between all this different RF, because you've got your video transmitters, you've got your ELRS, you've got a second ELRS, and you've got your GPS. So there's a lot of things that get packed back here, and you wouldn't want to put them any closer than 30 millimeters. Thankfully, we engineered it so that this is at least 30 millimeters away. So cheers. And everything is set up so that it has the least possible amount, but there is limited options. And you might be thinking, well, geez, why on something like this flip mode did we put the antenna at the front and then at the back, when on the sync mode we've got it at the back and then a vertical on the back? And the answer is really space, or kind of the opportunity cost of space. On a 5-inch drone, it's common that you'll want to mount something up here. And one of those things is definitely a GPS, because it's always got good line of sight to the sky. Your battery is sitting behind it here, so you'll have a really good signal up, into the sky. Now, the problem is that that's also the only place that you would mount something like a GoPro or an action camera. And there are many, many 3D prints that are included with the Superfly frame to do that kind of a mounting. But to be honest, if your GPS is mounted here, you now have a real problem with mounting your camera. You can also mount your GPS on your camera, but now you've got to be running cables quite a bit farther. It's a lot more, let's say, easy to damage, because those cables are shielded. If the shielding becomes damaged or your battery has a problem, your battery can slip forward and damage, basically push the camera out. A lot of the time when you're ejecting, what's happening is you're coming in at the ground kind of forward, and your battery's maintaining its momentum forward. So you're not normally losing your battery out the back of the quad. If you're losing it, it's going to be forward, and then through your camera, through your GPS cables, which aren't especially... Where can you fly this? Okay, so where can you fly this? Basically, you just need to be following the rules, and I'll speak to Canada. So Canada makes it so that anything that's under 250 grams, you can fly in uncontrolled airspace. You don't need to get a pilot's license. What do you got to do for over 250 grams? You've got to basically go and get a $10 multiple choice question answered for the Canadian government. You just fill it out. It's all on Google. Super duper simple. You then put a registration number on this guy. And for us, we've got a registration number just label printed on the bottom. And then your main concern is avoiding controlled airspace. So without getting too into the weeds, you don't fly around helicopter pads, you don't fly around airports, you don't fly where there's commercial activity, things like, drone, like a mine, for example. You probably wouldn't want to fly around a mine, or honestly, around people. So where do you fly this? You're going to fly this in a field. You're going to fly this where there's space. I know, WingSmith would never officially tell you to fly around abandoned buildings, because that's probably dangerous, but Bando is a name of abandoned building flying, so this thing is designed to basically do bando. It's designed to be able to fly around trees. It's kind of designed to be able to take a hit. So you just need space. You're not going to fly this thing in like a soccer field, because the soccer field is going to get crossed in about 2 seconds by something moving at 150 kilometers an hour. But you would be able to fly this thing, say, outside of town at like Wanuskewin, or if you headed down to Whitecap. I know there's some great sites out there by the river, and there's lots of places around town. Saskatoon actually is a great spot because you're just so close to the edge of town. I wouldn't probably fly this in Briarwood, but I would just drive 5 minutes out of town in literally any direction, and you can rip around a field. So we're working on basically setting up some fly days, and that is something that we'll talk about more as we go, is just meetups and setting up some gates, and not necessarily doing racing, but just having the obstacles and things like the soccer nets and the gates and different time trials and stuff like that, so that we can all get together and do this together. But for right now, we're working with some guys out of Edmonton, and there's a guy in town here who's trying to set up a chapter of, what is it, the Drone Racing League? It's a GT? I don't know. It's some kind of like drone racing chapter, and we don't build technically race drones, but they're certainly capable of racing. So, can you fly in a park in Saskatoon? I wouldn't fly this drone in a park in Saskatoon. It's pretty big, pretty heavy, pretty fast. And again, officially, I would never say that you would fly a WingSmith drone in a park, but a field of approximately a soccer size would be appropriate for something like a Hummingbird. There may or may not have been times where this particular drone has been tested in fields of that size, and we've had a lot of fun, and honestly people have been really, really cool as long as you're flying safely. So it's not really about the size, although that is certainly important in terms of the risk. But when you're a small drone like one of these two, and you're flying like not around people, you're not going to your property, you're just kind of like going through some soccer nets or around some trees, or you're making sure to like stay low to the ground, you're not going, let's say, over a fire hall or a police station, then you're likely not going to have issues with a small sub 250 drone. And even though we've got this guy registered, because we do set like a heavier battery in here, we do sometimes take this drone, this is the Hummingbird Pro, we take it above 250 grams. We've not had any issues with like people being upset or anything like that. So I would say use your best judgment, don't be a dick, that's the most important rule, and try to be considerate. And these smaller ones are great for something like a soccer size field, but something like a 5-inch, you would need considerably more space, and I would personally fly this in something more like a like out of town, or there's something like the Swale. Is that what it's called? The Swale? That could potentially be, like, you got to make sure that you're out far enough away from the airspace of the airport and like the helipads. But again, as long as you're being respectful, you're following the rules, and like if people ask you to move or what you're doing, that you're just respectful about it, we've never had an issue. So hopefully that answers your question. Oh, I'm getting confused. We were actually talking about the SyncMode instead of these other guys. But yeah, this guy's been popular. Let's talk about what you can do with it. So we've done GPS, we talked about the action camera, and I don't have a GoPro with me, but basically it just sits right here. We do a standard fixed design. Here, I got a quad mula mount, and you can see that it's really just 3 teeth. The GoPro fits right in there with a standard mount, and it actually comes with that mount, so you don't have to do anything special. And then again, this one's for a different quad, but it just sits right on top. Now, you do add some wind resistance because that's where the camera is going to be, and it's a giant brick that sits on top of the drone. So, you might think, oh, this drone is going to struggle. Your battery life is going to be affected, but this drone has a 5 to 7 times its like thrust to weight ratio. So that means that this drone weighs about 450 grams, and then a battery weighs about 200 grams. I'll show you here. Got 0. Put this guy down. 420. We got a standard 1400 milliamp hour battery here. 630. So the battery itself is approximately 200 grams, 210 grams. So you can see that as you get up around 630 grams, that's a chonker. Like, it definitely moves. And this guy can carry 5 times that. So we're looking at maybe 3 kg in total. I'm not encouraging you to fly with 3 kg. Obviously, it's not going to fly as well at 3 kg. But there's significant lift. So if you put something like an action camera on the front, you're not really at risk of impacting your thrust to weight. Like, you're going to fly fine. You're just going to have lower battery life. And so hopefully that answers some of those like kind of early questions. Obviously all these pink parts are 3D printed. Maybe that's not obvious. All these pink parts are 3D printed, which means they're effectively expendable because you can print these at home. That's no problem. We've done lots of different colors. You know, we've got this little cyan, we got green, we got pink, we do purple, and all of these are posted on the website. So you can download them, edit them. I've honestly used a open source software called Onshape. I guess, well, I want to say open source. The files are open. They're public files. So I can even send the files out so that people can edit them and manipulate it and do whatever. You know, we're just here to support, but the idea is basically to give you options. We redesigned some of the ones that came with SyncMode because when you buy from Superfly directly, they can sell you stuff. It's relatively expensive, which is fine because they are shipping it quite a ways. But when we do the printing of it, like, that's why we bought so many 3D printers, so we could support so many different colors at the same time. And if somebody has a request, like if somebody wants a particular change, we can do that. So feel free to reach out anytime and ask for, you know, hey, I'd prefer the vertical mount to be on the opposite side, or I would prefer the GPS to be for a larger system. Maybe you really like remote ID and you want it to fit your remote ID system. Well, we can do that. We also have this for like dual antennas, just like it is here. We can make these bigger. We can design feet. We can do other types of mounts for like things like GoPros and action cameras. So world's your oyster. You guys can design it if you want and just share it around, or you can ask us and we'll design it too. So that's the basics. Otherwise, let's take the top off and we'll take a look. One convenient thing about the SyncMode is that it only uses M2 screws on the top. So with things like the Flip Mini and even the Quad Mula Jin that are smaller, you have to kind of go back and forth between the 1.5 and the 2. And if you're not taking your drone apart a lot, that's not a big deal. And if you build a lot of drones, that's kind of a pain. So your mileage may vary, but it's really nice to have these kind of high quality M2 screws instead. And there's only 5. On the Quad Mula, there's 8. So that gives you a bit of a idea of like what this cage is doing, because if we're just taking the top off the drone, we're only taking 5 screws out. If you're taking the cage off, you're taking 8 screws out just for the cage. So the Quad Mula has 8 total to get under the hood. This guy has 5 if you only care about getting to the electronics minus the camera. But if you want to get the camera out, then you do pay a little bit in terms of the, let's say, convenience with the durability. So durability is super high, convenience obviously goes down because now you've protected it way, way, way more. Okay, so I must have a screw that's still hanging on here somewhere. Alright. 1. Okay. Go. There we go. Alright, so when you're taking this guy off, it just flips forward. We've got our battery cable routing through a little cutaway at the front. So I'll pull it off. Yay! let's pull it to the side here. Okay, so you can see how we've got our components arranged inside. This is a relatively clean build. We can do some things like shorten some of the wires, but as you can see, like our beeper is up the front, and instead of routing the wires all the way across the flight controller and potentially providing gyro issues with vibration, we've routed it through the back around the post here and then underneath. So this gives us a really clean look at how the computer is thinking. On top, we've got two antennas, and this is the second ELRS. This is a 90mm cable that runs to the back, and I believe this is a 50mm cable from HD0. I tend to like the ones from Radio Master a little bit better, mostly because they have these what do you call them, like rubber end caps, and then everything is rubberized on this guy. It's super nice. It's really hard to wear down. Like, we've done some real banging on this particular drone, and you would not be able to tell that this is not brand new. Like, this antenna works super good. This antenna has no end caps on it, and so it might be a little tough to show, but you can see the wire at the end there, and that's the transmitter. The most important part of the ELRS is the ends, because you're basically creating a donut of effect around here. So when you connect, even though you've got a horizontal like antenna, the only path that isn't affected by this antenna or like isn't getting transmission is directly out the ends. Basically what it's doing is creating a donut around this center, and so you can see that we've got like a vertical donut, which when you're flying close by, when you're like less than, say, 2 kilometers, is going to be fine. When you go farther, that's when things start to get a little more interesting, because while your drone is flying, let's imagine you're over here, you can be this solder, while you're flying away from yourself, your antenna, as long as you got clear line of sight, is going to be transmitting just fine. Like, you can be over here, you can be over here, but because you got a donut, and this guy's also got his donut, you are going to be, like, your two donuts are going to overlap. It's donutception. But if you go out a long ways, and you turn around, all of a sudden, this is now blocked by a lot of electromagnetic interference. You've got your flight stack in here, you've got your video transmitters here, and now you're going to have your battery on top. And so it's not really the placement of it, but it's just the orientation towards you. So why do we do a vertical one? Well, because imagine you've got your donut that's vertical, and then you have your horizontal donut. This guy actually sticks out below the frame, and so it will basically always have a line of sight to your drone or to your controller, because even if your top is on and you've got your battery here, it's like, okay, if I'm like this, then the bottom of this antenna can still make line of sight to my controller, even though the top is blocked. And if I were to like orient like this and say block my bottom, now my top can get line of sight. So this is known as diversity. It's called diversity ELRS. It's built right into the flight controller from HD0, and it is super useful if you're going to be doing something at relatively, now 2 kilometers isn't super long range, but I personally wouldn't fly much farther than that with just the basics. I might start looking at a long range setup if you want to go like 5 kilometers. You certainly can do that. Like, the rating on the camera VTX from DJI and from the ELRS is that you can do that. It's just that you're taking more risk, and you'll always have to be aware of the things in between you and your drone, because water especially will interrupt that transmission. So if you got trees, for example, in between you and your drone, you're going to have a far reduced signal. Also, if you have a hill, Like, rock also stops transmissions. So look out for water, look out for rock. Otherwise, you should be fine. And that is what really makes this such a great kind of like all-rounder for a 5-inch, is because you're going to have the best possible quality in your 04 Pro unit. You, again, can run it with really any camera, but this one works really well. You can also step to the like standard 04. You'll get a little bit less transmission strength, but you're going to have a cheaper camera. You can also put a racing stack in here, or like a, let's call it a high-powered stack, because not everyone's going to be interested in racing, but it's conformal coated on the ESC. We apply a hydrophobic spray to the flight controller, and if I've got it here, I'll actually show you. Thank you, baby. So this is not a conformal coating. This is a Flywoo Ultra Hydrophobic Spray. What that does is basically makes your board hydrophobic. It doesn't like water, and it'll run off. Now, the difference is that conformal coating is kind of like a plastic. It is, or like a rubber. You apply it, and then it is on there for good, for better or worse. So you can solder through it, which is fine, but it can make things difficult, especially things like barometers and plugs. It's not easy to work with either. Like, if you're building a drone on your own, then it's totally reasonable for you to conformal coat the flight controller and the ESC. But with this board in particular, with this stack, this electronic speed controller comes conformal coated. Great. We don't have to do anything. We can, I mean, we have to solder our motors to the, to the pads and set up our battery and capacitor, but in terms of water protection, it comes water protected. Unfortunately, none of our gyroscopes, barometers, the things that are actually pretty affected by things like conformal coating are on this board. So the flight controller does not come conformal coated. That's where we use this spray, because it's incredibly easy to apply. You can do it with either a brush or with aerosol. And if you're doing it with aerosol, the only thing you want to watch is that you don't cover your barometer. A barometer is basically a pressure sensor, and it measures the ins and outs of air so that it knows effectively how fast and how high it is. It's part of the computer that is your flight controller, and you just want to make sure that you cover it with tape if you're applying it yourself. The other little downside of this is that it is consumable. You will wear it off slowly, whereas conformal coating doesn't wear off as quickly. But the huge advantage to this is that it's incredibly easy to reapply. And if you want to, reapply it to your flight controller, all you got to do is unscrew these 4 nuts, and this guy basically pops right off. You can give it a quick spray, again, remembering to cover the tab with the barometer, and you're basically good to go. You probably also don't want to spray it into things like the ports, so you can use a little rubber plug to prevent that, and your UFL connectors, you can also just spray it. You can just leave your UFL connectors connected and spray, and you'll be fine. So this is really the 2 methods of waterproofing that we use on something like the SyncMode, and help it just be even more reliable. So, okay, what else can we talk about? I guess the last thing before we get to soldering or do something else is these covers. You don't have to use these like motor guards. We went in with 3D printed parts with these zip ties, and some people might not like them. Some people might prefer the little plastic ones that you can purchase or that come with a lot of bind and fly drones. And we tested a lot of different methods, and what we found was that even though aesthetically the like clear plastic ones that you can purchase are really nice when you first receive your drone, they get a lot of a wow factor. What actually happens is they've got an adhesive on the bottom, and when they crack and break, they can become extremely hard to get off your arms without delaminating them. So you can damage the carbon fiber by taking those things off because of the adhesive that's used. I'm not sure, I've never seen them. There's a version that has like a zip tie fixture instead of adhesive, But this allowed us to do different colors, and to be honest, these are soft. So while the hard plastic shatters and create basically edges for you to cut your motor wires on, which was also a negative, the TPU allowed us to just print a zillion of them. We can make them in any color, and we can modify the size as much as we want. And they're really cheap. They're soft, so they're never going to shatter. If they rip, it's okay because they're cheap and they're easy to replace. And they actually do a better job in things like cold weather than these brittle plastic covers. So some people might look at this like you cheaped out with your TPU motor covers, but that's not the whole story. The whole story is, yes, they are less costly, but they're more effective, and they're actually better for Canadian environments. And when you're flying in a grass field, like is common in Canada, you want to have colors that don't necessarily show up in nature. So something that's pink, I mean, not only does it look cool, but when you lose your drone in that high grass and you're hunting for it with the beeper, way easier to see when you got a pink or a bright green like this. If you're in like a yellow field, or even a cyan like this with the black. Yellow also good, but you gotta be like conscious. You're trying to be observable. You're not trying to be stealthy, because if you're stealthy, although it looks cool while it's flying, if you bring that down in the wrong place, it can be super hard to see an all black design in a high grass field. So this, even though it looks maybe silly, or you might have your preferences on like how they're designed, it actually serves a purpose beyond just being inexpensive. They do the best job for our environment. So, if you're flying in China, that might be different, but in Canada, you need to consider like certain things, and finding your drone is one of those things. Okay, so let's get on to some soldering. Actually, I'll just really quickly show you the parts of this drone first. I got this bag, and I promised that I would get this guy out. So this is probably the most important part. We'll just pour everything here. All right, we got our forearms, we got our bottom plate, our top plate, our camera cages, and our X mounting. So in this package, the hardware is not included. There is hardware that is included separately, but I'm just going to show that like the carbon part, because the screws and everything come distinct from it. So the most important part, this is the base plate. You can see that there are inserts that are already installed. So Superfly has gone through and basically put the receivers for the screws into the base plate, and that's true for both the like center mounts and the wide mounts. The two screws are necessary for each arm, and then they meet right in the center. They basically got a T design so that they align, let me just show you, in a way that allows them all to touch. This has some benefits, again, where you sacrifice convenience for strength, because the quad Mula frames use what's called a C-mount. They do not meet in the middle. They meet on the sides in kind of like more of an H structure, a squashed X design. There's actually a plate in here, and there's 4 screws where the plate acts as your lock. It has a little arm that sticks out, and going forward, going backward, and then you only need to remove 1 screw on each arm, which is extremely convenient. This is perfect if you're going to be like, bando bashing, or you want to be really throwing this thing around maybe over concrete, where you think you're going to be changing your arms, because a 1 screw is obviously half the work of 2 screws, but even beyond that, you can just slot these in and out, and you're going right underneath these standoffs. So it makes it really convenient. However, when you have 2 screws in each of your arms, what you're really saying is that you're prioritizing your strength over your convenience, because 2 screws are going to be a lot more durable than a single screw. So this guy approaches the problem from a different direction. It basically builds redundant strength in through things like its carbon camera cage, its extra screws for the arms. It also helps with vibration because now you have, like, as long as your screws are tightened properly, you're going to have 2 points of contact that are both working against the propagation of vibration. But it does make building it a little bit more time consuming. Otherwise, you've got these, what are they called? Countersunk holes here for your screws, and that's how you know which one is your bottom, because you can see that the screws and the arms fit flush to the bottom plate. And so you're going to be doing the same thing. You want it to be aligned so that this is flush. On the other side, you've got your receivers, and these stick up just a little bit, but your screws don't actually penetrate through. They just become flush, and so your motor wires are still fine. There's no sharp edges to catch on. So it's well designed. It looks good. And otherwise, the most notable part about it is that it's a single plate. You can see it's just one piece. And something like, I'll get this equivalent quad mula. This guy's got 2 different plates. It's got a front plate and a back plate. It's called a split plate design. This is really good when you want extra space between your in vertical at the front, which is especially important for things like your camera. We also had a hell of a time vertically mounting our capacitor and our buzzer on this one because the space is so limited that if you were to lay it flat, you actually end up with a problem where the buzzer is almost coming into contact with your ESC, and when your camera's in here, it's butting up right against this print. So without getting too in the weeds, this print right here took more time than any other print. It took more than every camera cage, more than every VTX holder, more than any foot, more than anything else, was this print, because the space was so tight that we were working with like a millimeter of kind of give in any one direction. You might also be able to see that if I do the camera just right, there's actually, this buzzer penetrates a small cutout of the top plate ever so slightly because of how tight it is at that angle. That is because you don't want to put your battery of the self-contained battery of the buzzer right against the bottom plate, because if you have a bad crash, you could damage your battery, and then you got to replace it, and it's definitely kind of a pain to get that guy out. So we specifically designed this so that it wasn't coming into contact with the plate here, the bottom plate, and it penetrates through the top plate on the plastic part, because if that connects, it's plastic on carbon. You're going to be fine. Like, that's not going to be damaged, but you don't want your battery having a hard crash. So the button is accessible. It's mounted next to the capacitor, which is on the other side, and this is a full size, what is it called? High capacitance capacitor, ZHL design. So it feeds a really short cable right into the battery leads there. And then you can see that we've pulled this guy apart in terms of the soldering. So we'll put them back together here in a bit. But this is just for an example. This is what is necessary. Like, it is tight in there. When you go to the sync mode, you don't have any vertical distance. Like, you cannot mount this vertically. Not only is it really short vertically between the bottom plate and where the top plate sits here, you got maybe maybe 20 millimeters. What you're also running into is that they've put these posts in here to add strength to the camera cage. And you've got this middle post. So there is significantly less room in here to work magic. There's basically no way that you can vertically mount this with the post being here unless you have a really long TPU print. And then you've got the same problems of the camera, this cage exists way behind this camera. So you end up with a super tight build. And so again, this was one of the harder prints, easier than the quad mula because it's a little bit longer in here, but this difference of a single plate design versus a split plate design actually does have some pretty big impacts into the design. And this is going to be stronger mechanically because it's just one piece that's got a lot more mechanical strength, but It's definitely more complex to build with, and a split design gives you more space to work with. Even though, you know, this was really hard to design, this gives you more vertical space and honestly gives you an easier access to your arms below. So it's kind of a trade-off. It's not that one is better than the other. The Superfly does a great job of like designing to be what it wants to be, a bando basher, where you can just like really give her and it's gonna take a hit. Whereas the Quad Mula is designed a little bit more for convenience and for doing lots of changing. So if if you're confident that you're going to, this basically avoids the changing by saying I'm not going to break in the first place. Whereas the Quad Mula accepts that people make mistakes, and if you do hit something wrong, it's going to be easy to swap it out. Okay, so otherwise, I guess the most interesting part is that these things all just like fit together. So you can see that there's kind of a lever mechanism to put this together. It fits on the top. This actually penetrates under the core of the body here. I guess I got that upside down. So you've got a locking mechanism here, and that's that. So now that we've looked at the basics of the SyncMode, let's do a little cleanup on our soldering, just so I can show you guys what it looks like. And we haven't said hi to Carmen, so I'll pass this off to her while I'm getting ready.
Oh God.
I know, you're on camera now. So I'll be right back, everybody. Here's Carmen. And we've still got, we only got 12 minutes? Whatever. I'll maybe go a little long then. If you guys want to see BetaFlight, just let us know.
I've been over here working away trying to organize our storage because, well, it was absolute chaos, and it still is. And we definitely don't have enough containers for all of the supplies we have coming in right now, but it's getting there. It's a process. We have a lot of shipments arriving over the next week-ish here, so we kind of have to just make space for it all.
Just put those there for now.
Yep, mess up my whole process, thank you. No, that's fine. So yeah, that's basically what I've been working on in the background, is just trying to get everything organized and a spot for everything. We've got a label maker, which has been my best friend recently. I love it. But way less interesting than what Richard's doing.
I feel like I talk too much.
No, you talk a great amount. I struggle with the whole talking thing, so that's I feel awkward.
Do you want to show them how we mount the camera? Maybe people are interested in the behind the scenes. So, hey everybody, this is the workshop. And while there are many things that we do that are fancy, this isn't one of them. We got a basically arm here to mount our camera, and this is how I've been showing you what's on the bench, because it's either hold it, which we did for a little while, or we bought a little holder for our phone. It's got a little clamp. So
makes pop down really easy.
yeah. Now we're still gonna have to figure out things like OSD and like how to share, both ourselves on camera at the same time as something like our simulator, because we'd love to walk. We do a live stream just to show you the walk through the simulator. We're going to be working on a liftoff tutorial to they've got their own, which is perfect, but we want to create some courses and just help get people flying, because I see a lot online. I'm just going to rant for a second here. I see a lot online. And I'm shaking my finger a little bit because there's some people out there that are going to tell you you need 100 hours, 200 hours, 500 hours on a simulator before you fly a drone. That is not true. You do not need that much time. It is a good idea to use a simulator first. You absolutely should use a simulator before you try to fly an FPV drone. But in the range of 10, 20 hours maybe. You can totally go out there and fly in, they call it hover mode, or I think it's called angle mode. And it's basically where your angle is limited, so you can't go all the way, you can't flip the whole thing, you can only go so far forward. There's no reason you have to do more than 20 hours of practice in a simulator and feel like you can't go out there, pick it up, and put it down. You'll get a lot better, a lot faster, if you actually get your thumbs on the sticks and fly a real drone. The simulator's just there to get you started, and then to practice things like tricks, because obviously the first time you try like a loop-de-loop, maybe you don't want to do it on your real drone. You can try it in a simulator, and you'll figure it out, and then you go to do it in real life, you're going to be fine. Like, things, you know, you're going to be great. Practice over grass. Maybe don't practice in the IKEA parking lot first time.
Yeah, or like over a lake.
Or over a lake. You probably don't want to practice the first time over a lake. That's a harder recovery than walking to the middle of a field.
And I'm sorry if I butcher your name, but Dimitro says he would like to see BetaFlight.
You want to see BetaFlight?
Yeah.
Okay, so is the office clear? Can we go through there?
I'll have to double check. Yeah.
Okay, let's do that. We can check out BetaFlight. Okay, you want to see BetaFlight. Cool, cool, cool. No problem, man. Well, I'm going to show you this guy in BetaFlight because, to be honest, we've only got, you know, I can probably do another like 20 minutes or so, but this guy has a longer configuration because nothing on him has been done before, whereas this guy has already been set up, so I can show you a review on it a lot faster and like, you know, we can do troubleshooting on the SyncMode, we can go through the whole setup process, but to be honest, it just takes probably 40 minutes, and it's not the most interesting thing to watch me get settings set up the first time, whereas rifling through settings that we've already got set up and getting straight to like a motor test or getting to ELRS working, like I can show you those things and then we'll come back later and kind of fill in the details. I can do a whole live stream on that another time, so let's get set. I got my drone. I think there's a battery in there, but you got to take a battery with you as well when you're going to be doing these tests because the motors only work if you've got a battery plugged in. Let's go take a look. Okay.
And then we would look back and he would stop and he would just look really embarrassed and it'd be like cute. That's adorable.
Lots of activity. Here's the print farm. Look at us going. Crealty heater. We got 4 different colors in here. Look at the doggos. Hey, doggos. We've got our BetaFlight computer. So this is the part where I'm going to have to do a little bit of holding, I think, while I get everything set up. Okay. So, just give me 1 second here. We're sharing this office, I guess, and I don't know what they did to this computer. Turn it on. Turn it on. Cool, cool, cool. Jeez. Okay. Turned off my stuff. All right. Other 3D printing. Stuff. Cool. Okay. Okay. So let's get started. We've got our drone. I'm going to find a convenient spot for this camera. Well, I'll do this with one hand until we figure it out. So we got our drone. I'm not going to need my headset for this. There's nothing in BetaFlight that needs a headset. And I got my battery, I got my controller, and I got some goggles to test with. Sounds good. Okay, so the fan is here for when we plug in the battery. We want to run the fan underneath it and basically stop the VTX from getting hot. When you plug in a battery, your video transmitter is going to start putting off heat. Normally that is handled by flying around and the air passing over it. There's also a heat shield on the these Flywoo versions, and they've got some thermal paste between the board, which is the USB plug there, and then the little aluminum or whatever cap on it. So we can help that by basically putting a fan and simulating wind, and the 3D print has a whole bunch of cutouts in it to allow airflow. So even though it's a little tough to see here, just the air passing over this is going to be enough to cool it, and we can simulate it with that fan. All right. So I've got BetaFlight here, And BetaFlight Configurator is a web app, but you can also just like get a version that is kind of like an application on your computer, and you get your welcome, your privacy, etc. The most important part is that you've got your device up here, and I haven't plugged anything in yet, so let's start there. Got my drone. You got basically two USB plugs on here. One of them is on your flight controller, and one of them is on your video transmitter. So if you do your plug into your video transmitter, you're actually going to be pulling the video off, and that's great when you want to like get video on your computer. But I just plugged it into the flight controller there. Oh, and you know what? I'm going to want to turn on my controller as well.
Welcome to HTX.
There you go. A little hard to show, but we got it on. Great. So it's on. Got a little blue blinking light. Good, good, good. So our drone is connected. We're now going to come back to BetaFlight, and you'll see that things have switched because sometimes, as in most of the time, it's going to automatically detect that you've plugged in a drone. You'll see that I have no battery plugged in. I'm just running off USB power. This guy has a gyroscope, which is true. It's got an accelerometer, which is true, but it doesn't have a magnetometer. It doesn't have the baro is fine. It's working. The GPS isn't connected. There's no sonar. Cool, cool, cool. All right. If you want to disconnect, you can use disconnect, and if you want to update your firmware, you can use it right here. And that's used if you want to just set things up, kind of like you want to update, obviously. So this is kind of cool. I'm going to bring my drone over here, and I'll do my best to like kind of make this easy to see. But you can see that I've got my drone facing, let's say, into the screen. I'm going to do this here. I'm going to click reset Z-axis. And all that does is reset this model so that it's facing directly into the screen. Now, I've got this guy on a mat, so it's probably not 100% like perfectly level, and so you can see your yaw, pitch, and roll there. But as, you know, this is how we're going to check that the accelerometer is working. As I pick it up and move it forward, our model is reacting exactly how I'm positioning it, and it should be basically instant. If this isn't happening, you've probably got something that's messed up, and you can fix it with either a firmware flash or you can fix it with some settings, but basically this is what you'd expect. If it's just running slow, try restarting BetaFlight, because I've had that problem before, and it's honestly kind of fun just to like, whee! If you want to change these values, like if it's not reading basically 0, you can say calibrate accelerometer, and it'll basically do that. So let's place this guy. It's on a flat surface now. We can see, oh, you know, we got some pitch and some roll, like, oh my. So we're going to click calibrate accelerometer. It's calibrating. It's done. And you can see now these should be basically 0. So it's pretty sensitive, but again, when I pick it up, whee! Cool. All right, so that's the basics. This guy doesn't have a GPS in it, but this is, you know, where you can see some of your GPS tags. You've got your instrumentation, and so when you go to take your flight test, you know, you're like an airplane. Look at me. I've never used these instruments other than just to check that the accelerometer is working well, but it does help if you're just like having some fun. So let's see, sensor info, that's the right gyroscope. You can have an MP66 or an ICM42. You know, this is low. This is basically all set by the board. You got our firmware info, so you know our build, when we did it, etc. If you are looking for your build, so let's say you receive your drone and you're like, hey, I want to make sure I've got the latest firmware. I've got these features that I really want in whatever version of BetaFlight is brand new. How can I go check it? Well, you go right to the top left and you see your firmware version, and this is 2025-12.2. So they switched BetaFlight at one point from like version 6, version 7 to basically the date. And the idea is that every 6 months they update this. So the newest version hasn't been released at this point, although it has been released as a beta. At WingSmith, we do test the betas, but we don't release them. The betas tend to not be as stable as just like the proper production targets, so we just leave them until they're fully updated, and we'll always release with the most up-to-date unless there's a problem. And then this guy is reading the HD0 Halo, so that's the board, and that's the target of the firmware. So it's basically saying it's BetaFlight, it's running this version for this target, and that's the basics. Next, we got ports. And I'll just give a really brief description. This is assigned manually. So what you do here is basically come in and tell your flight controller what it should be reading. Now there's 3 things that your flight controller is going to be reading right now. One of them is going to be your, I believe, which one here? Okay, so if I zoom out a little bit, this UARTS 5, we turn it on and we configure it, but we're going to make sure that this guy is our VTX DisplayPort. Because we're using a DJI headset, we need to be able to bring the information from the DJI camera into the board because it has its own OSD. This is going to be a little confusing. OSD stands for on-screen display. If you're using an analog system, you're the only one that sets the on-screen display. But DJI has the best quality cameras, so we went with them. They run a digital system. And with their system, they have their own on-screen display, which tells you basically like the battery that's remaining on the goggles. It has its own menu system. And so you want to be able to bring all those things into your video stream so that you can see it. Then what happens is you're allowed to overlay stuff onto that default. So DJI keeps theirs pretty minimal, and then you can add things like your voltage or your GPS information on there as well. A little off topic, but are we getting a custom tune from you guys or the one Superfly gives with you the purchase of SyncMode frame? So what we're doing, let me just walk you through that part then. We come through to the presets and we do the Superfly, either the 5-inch or the 3.5-inch, and we do like slight, very, very slight modifications to the defaults. But the idea is basically that when you purchase a Superfly frame, there is like a tuning tool that Steve includes with it. It's as a PDF, and so there's things like your master modifier that is included with that. You can put your weight. And the reason that we don't do that is because while we are, making the drones with a recommended battery and like it's all recommended, the idea is that everything is configurable. So you can change the motors, you can change your flight stack, you can change your camera, you can change your antennas, you can change your battery most easily. And if you change your battery, you can really quickly adjust or modify your tunes. So we've kept it pretty basic, and it's going to be like the presets from Superfly, and we do that on all the drones. But then if you'd like, you can go into your PID tuning and like specifically tune it to whatever you want, because this is kind of a personal preference. You can set the sticks to be as sensitive or as less sensitive as you'd like. We don't really get into changing the defaults because for someone learning, our opinion is that it's better to learn on the defaults with the tune and the PIDs. And then as you become more comfortable, you'll understand what you'd like to see change. Now, we can always help change stuff. If you'd like us to help with any of that, you're welcome to reach out anytime, and we can totally like walk through this in a little more detail. But it sounds like you might already be aware, George, or Gregory, of what you want. And so if you're already familiar with PID tuning, if you're already familiar with more in the presets, you're welcome to go in and change it like BetaFlight. We don't lock any of this down. It's totally open. And if you need help with something, that's what we're here for. But we wanted to embrace some of that, like basically some of that community effort or the default settings to give people the power to make the changes they want. Okay, so then we've got a receiver. Now, this is a little bit tricky because I got only a couple of hands, but as I press things on here, you can see that the drone is responding to the different button presses. And so if I do my throttle, you'll see that. If I do my yaw, you'll see that. You can see my roll and my pitch. And so this is all basically just showing that our ELRS transmitter is set up to our receiver on the drone. And easy peasy. Finally, let's talk about our modes. This is how people can modify their controller. So we, in a kit, will set this up with the WingSmith default. And right now, this is entirely changeable. Like, the idea is that you're not locked down like a DJI system here. If you want, if you really want, you can change your sticks in your, it's called a mode. We are on mode 2. You can change it to be mode 1, mode 4, mode 3, whatever you want. If you would, like your different flight, what are they called? Like, we default to angle mode. I'm sorry. We default to acro mode. So acro is where you have basically full manual control, you're flying. And the idea is as you become more comfortable with FPV, that's the default. You'll probably fly on the most, so we leave it as the default. But if we switch this, you'll see that we bring on horizon mode. That's kind of like a half step between angle and acro, where you have limited, it's basically limited angle until you get to the end of the sticks, and then it does allow you to go farther and faster. But if you flip it all the way, you get to angle mode, and that's where your angle is limited. So that's like kind of your learning tutorial. So when you first get your drone and you're just like, I've done my 10-20 hours in the simulator, I'm ready to step it up, you might feel most comfortable setting to angle mode and just going up, going a few feet out, coming back, coming down. Like, just learning how the drone flies and operates and getting everything connected. Then when you're ready, you can switch to horizon mode, and it gives you a little bit more freedom. You might take a couple of bumps, but you'll learn really quick. And then your default is acro mode, and that's where I'm most comfortable because I like having full control. So there's really not that much to show on the controller. Once it's connected to the drone, it's working. And this is just another way of like setting your controller to do different things, whereas your receiver shows your different parameters, and like you can mess with it just to like make sure everything's doing what it's supposed to be doing. We have telemetry turned on, which I'll show you some neat tricks about that in the future. And then our motors. So this is going to be the last thing I show you guys in the live stream, but it's one of the most fun. I am going to now get my fan going, or maybe I can get Carmen to help me out here because I only got a couple of hands. So would you mind just setting this up?
Yes.
Yep, and then if you wouldn't mind, I can't seem to get my ELRS synced with my drone. I need to hire you guys. Oh man, we can do that. Like, we can totally help you out. And if you just want to like set up a chat, that'd be perfect. We wouldn't even charge you for that. Thank you, sir. I understand where you guys are coming from. Thanks for the answer. Looking forward to mine showing up. Hey, no problem at all. Hopefully that I'm kind of rambling as I show off the different features, so hopefully that makes sense. But like, anytime you want to reach out, feel free. Like, we're here to help you because we know there's a lot to get used to. So Carmen is helping me out. She's just plugging a battery into the drone, and this is how the fan works to keep the VTX cool. Ooh, she's gonna do it fancy and put it right in the
Gotta be all
battery strap.
Gotta be all proper, like.
Wow, very nice. Cool. So that beep was the beeper going off, and that's what you want because you want it to be working. And the last thing we'll show you here is these motors. There's basically two things to show you. One is the order, and one is the direction. So right here, you'll see that we've got the motor spinning in a motor direction is reversed. Shocker, because there's two ways to do it. Either the rotors are spinning away from your camera, which is called out, like this is props out. do you have the DJI video transmitter and camera in stock? We're just waiting on them to arrive right now. So we will, but they are shipping at the moment. And just as a heads up, we've got the MP66 coming from Flywoo. So we will have the DJI standard in stock, but they were having a little bit of vibration issues. So we went with the Flywoo version, which has replaced the gyroscope with the MP66 and resolves that issue. And so if you see on our website that it's listed as an MP66 or special, that's why. It'll be in stock here hopefully in the next few days. We're just like waiting on customs. So it's a process, but it will be here right away. Okay, finally, these are motors out. If you do this, you're going to see that the motors are spinning towards the camera. It's motors in. We specifically chose not to do that because when you hit a branch or you got some grass or something like that when you're landing, throwing things into your camera is not as great as like the stack. The downside here is it's throwing it into the middle of the drone, but we just don't care as much if the middle of the drone gets dirty versus the camera. The camera is literally what you're experiencing the flight through, and if you happen to catch a branch or a leaf or something and it throws it into the way of the camera, you're gonna have a lot harder time than like, oh, the middle of my drone is dirty. So I'll show you the order. I understand the risks. All right, and we're gonna start. And so here we've got we're just gonna click as we see the drone order. And as we come over, okay, you can see that it's our bottom right. So I'm going to click that one. Okay, that's our top right. Cheers. That's our bottom left. Cheers. And that's our top left. Okay, so you can see, ready, check the motors are spinning on our recorded. We save. Sure, I'm going to save it. Why not? You can see that BetaFlight restarts. We get our little beeper. You can't see the beeper super well, but it's in this tail section here. And trust me that it's loud. So even though it's covered with a piece of carbon, there's a couple of small cutouts at the back there, and that little beeper really beeps. All right, finally, motors. We're gonna do our motor direction here. I understand the risks. And we're gonna do the wizard, because we like the wizard. And the idea is when I click this button, it's going to start spinning these guys, and this is how it's supposed to be set up. So the first thing, don't test with the props on. People hurt themselves when they test with the props on. This is part of the QA process, so don't do that. All right, so everything's spinning, and we're going to take a little piece of paper. In this case, we've got a Flywoo manual, and we're going to check which direction. Okay, so it might be hard to see, but this guy is now spinning towards the tail. We don't want that because it's supposed to be spinning in the other direction. I'm going to click this button. One is now reversed. I'm going to go back here. Oops. And now you'll see the motor is spinning in the right direction. Excellent. Now 2 is supposed to be spinning away from the camera. 2 is spinning away from the camera. Okay, what about 3? 3 is spinning towards the back. It's a little hard to show you guys as I'm doing this, but I'm doing my best. It should be, yeah, there you go. There you go. And then this guy is spinning away from the camera. Cool. So everything is set. We're going to stop the motors. We reversed 1 and 3. Motor direction is saved upon selection. Excellent. Close. And now, if you really want to check, because we just set our directions, we're really happy with that, but we're just going to do a test just to make sure all that stuff really stuck. So at the bottom here, you've got a basically controller for your motor test, and we've gone through setting the order and set it so that we know what 1, 2, 3, and 4 are. And then we've also done the motor direction, and now we're just going to make sure that everything is saved that way. So I'm going to take my master slider and slide it up just ever so slightly. Like, we don't need a lot of speed here. And you can see now all 4 of my motors are spinning, and we're just going to verify that everything is as it should be. So this guy is spinning towards the middle of the drone. That's good. This guy is spinning towards the middle of the drone. That's excellent. This guy's spinning towards, look at that, the middle of the drone. And then this guy. A little hard to show you because we got the fan going, but that guy's also spinning towards the middle of the drone. Excellent. So we're going to say stop motors. Bing bong. All right. We've got our D-Shot 600 over here. That's basically the ESC, like how often the ESC is sending and receiving information about the motors. And so we'd like that to, we'd like that to be high. Sometimes you have to set D-Shot to something lower, but when we pick the H743 processors, it should have no issue keeping up with the D-Shot 600. That's the default. We wanted to make the WingSmith drones all like as high basically response as possible. The other thing I guess I can show you is that when we plugged the battery in, we did have a voltage show up here, and so we're running a 4S battery on the Hummingbird Pro. We also do that on the Hummingbird, and then on the Falcon, that'd be a 6S. You can see that you've got 16.81, so we got plenty of juice in here, and this is the measure of all 4 cells. So each cell has a nominal voltage of 3.8, and so what does that work out to? 12.8 would be 32, so 15.2 would be kind of like the normal storage voltage. You can take each of them down to about 3.2, and I'm not going to get into it here, but taking them below 3.2, you're going to eventually start wearing down your batteries. And if you have a high voltage battery, you can take it up to 4.35. If it's a normal battery, it'll be 4.2. So this was a high voltage battery. If you have a normal battery, you'd expect that the highest voltage you'd see here is 16.8, because that's 4.2 times 4 cells, or 4S. And basically, that's how you do the math. If you have a 4.35, you'll have 35 times 4, you're going to make me do math, 1.4. So you're going to have 1.4 higher than 16, 17.4. So that's the math. It's honestly, it's not that hard. You basically are happy as long as your cells in your goggles are higher than 3.2. And so that's, I guess, the last thing I'll show you is the OSD. I know we said the last thing last time, but here's where you can set the different elements of your on-screen display. You don't see here where the DJI stuff would be because it's not displaying in BetaFlight. You just kind of have to know it. And so we've got our link qualities. Sorry, we've got our link qualities up here. Yes, thank you, controller. Link qualities up here. We've got our title up here. We've got our information about the ELRS here. And the weird thing about ELRS is that it's measured in negative decibels. If I'm here on the bench and I've got like my drone and then my controller and they're this close, you should see something like negative 30 to negative 40, which is totally normal. It's a very odd system. If you go to like negative 100, that's where you're going to want to start like considering maybe turning around. Negative 130 is quite a bit, but like world's your oyster, fly how you'd like. And then this is going to be your packet strength. So like this is a measure of basically like, without getting too into the weeds, and we can do that another time, these two numbers are both important for understanding your RSSI, and one is your dBm value and one is your RSSI value. And the most important part is to make sure that this doesn't go super mega high, as in doesn't become super mega negative. So when I say that 3.2, this is the voltage that you're looking for. You can set your low voltage warning to be different amounts, and that's in your battery screen. And we're going to set those as 3.3, maybe even 3.4, because at 3.2, you want to be landed. Like, you want to be back home. So let's just see, can I, boop. These are in configuration. Yes. Also, we mount our boards backwards. So you'll see that our board alignment is 0 for the roll. That's your left-right roll. You've got your pitch, which is your forward-back. and then you've got your yaw, which is like a flat spin. And because we're mounting this at 180 degrees, we enter it here, and that lets the gyroscope know when you're doing this kind of stuff, which way is forward. So that obviously helps. Okay, 8,000. We've got a minimum arm angle, 25. If you're more than that, your drone's not going to arm because it's too big of an angle. Power and battery. So yeah, you can see here our configuration. Our warning of cell voltage comes on at 3.5. Our maximum cell voltage at 4.3, and then our minimum cell voltage at 3.3. So we could even change that a little bit. I'll show you the tooltip here. The voltage that is considered critically low and will trigger the corresponding warnings, land now warning in OSD, and audible beeper if the beeper is soldered in. Also assists is cell count calculation. So this is pretty standard because, again, you don't want to go below 3.2 and 3.3 having, this is kind of like your, hey, you should come down, low power warning, and then this is like, oh my god, you should really be landing right this second kind of warning. So hopefully that gives you an idea. I haven't put in a capacity because this is different for the different drones, and we'll be changing based on what kind of battery you use. We do, recommend some batteries, but hey, we're not the police, we're not going to stop you. So if you decide to run something else, that's totally fine. Okay, so that was super quick, but basically covered our setup tab where we explored the different orientations. We got to set our accelerometer, and we got to see what was working on our board. We also got to reset the Z-axis to have some fun. We went through the ports where this is our VTX, and then really quickly this is our USB, and that's going to be something that's important for doing like our configurations for USB. And then this is our we got our VTX. Oh, this is our ELRS, so that's going to be how we're chit and chatting to our ELRS system. Oh, I'm sorry, this is not ELRS because ELRS is built right into the HD0. So normally there'd be another one here where we'd set it as serial, and I'm thinking, geez, oh, this is serial. Well, I'm sorry, guys. I'm trying to record and talk at the same time. But you can tell that this is our ELRS because when you have connection between your controller and your drone, it has to be serial. And so I'm just confusing myself by talking and filming at the same time. This is your USB, this is your ELRS, this is your VTX, or your video transmission. You don't need to set one of these for your beeper, because the beeper is its own pad. It doesn't need a UART. These are just the ports. So the ports might be a little hard to see, but they're the little there's one at the back there. And this is what your plug-ins, basically. Okay, then we're going on. Configuration, we've got our PID loop, we've set our yaw angle, we've got our flight modes, we've got our beeper. This is where you set your beeper. D-shot beacon configuration. This D-shot beacon is your motors going beep boop, and then they'll do it at the same time with your buzzer. So we set them both. You just got to watch out for a little bit of extra heat. Power and battery, that's where we set our stuff. Our failsafe is set to drop when there's a GPS involved. It'll be GPS rescue. And the part we're going to have to be careful on here is our throttle hover. So this weekend I'm basically getting these and putting them in the manuals and setting the GPS as they arrive. We've got our presets where we're going with the Superfly 5-inch on the 5-inch because it's excellent, and then we're going with the 3 and the 4-inch on the smaller ones because this one is also excellent and gives us just excellent presets. Then we're going to the PID tuning. We don't really touch this unless you want us to because default rates are great. They're not like, oh my god, I'm gonna win the next drone racing league without touching my PID rates, but for a beginner, there's literally no need to touch any of this stuff. It's set up just fine for learning. A receiver, well, this is where we got to see the controller, do the controller stuff, so you can see, woo! You got telemetry, which is useful for a couple of things we'll get into later. And down here is a little chart where you can see okay, I'm playing with my controller sticks. Look at that. Whoa. All right, modes. Hey baby, if you don't mind just answering that question. ARM, yada yada yada, all controller adjustments. I'm not doing any. GPS will be important when we have a GPS in the install, but that's not in this model. Motors, we've been through it. OSD, hey, look at that, that's what you see. And video transmitter we don't get into because this is handled by the by DJI. So that was super fast. We covered a lot, but I hope that was somewhat informative. We were moving at light speed because I know that people have things to do and this live stream went a little long, but hey, that's okay. We are here to help, and honestly, we went through an entire sync mode. Other than like plugging things in and doing some soldering, we can always do that another time. Soldering is just, it's fun, but I think since you wanted to see BetaFlight, this was a better way to spend our time. And BetaFlight takes quite a while to learn, so I've become pretty familiar with it now. I've been doing this for almost 2 years, and I am always finding new features. Joshua Bardwell and Oscar Liang are excellent resources, and I'm sure you'll see them online all over the place. But if you have any questions, you want to reach out anytime, like, that's exactly what we're here for. Yeah, I hope you guys are having a great day. So have a great Saturday. Enjoy your Sunday. I'm going to sign off here in just a moment. I'm just letting Carmen finish sending a quick message. But otherwise, that's been a day in the life of WingSmith. Yay! And so, yeah. Thanks so much, everybody.
Thanks, everybody.
I'll
This
just-
is a lot of fun.
Just post here.
The guy in the chair.
Have a great day, everybody, and talk to you soon.
Have a great day, guys.
Bye.
Bye.